So in the past few sessions, we were discussing about the working switch, how switch is able to communicate data between two different devices. Right. So, um and the diagram that we have been always looking at is like this, that there is a switch, for example, switch number one, and it is connected to different PCs. PC number one, PC number two, PC number three, and PC number four. Right. So this is what we have been looking at. So what I usually do is I give MAC addresses like this to these PCs, different PCs, and then we try to understand the working of the switch or the how switch will forward the data based on this MAC addresses. This is what we have seen, and we did a practical and practical for the past few days. We have been understanding this. So I hope we are clear of how switch basically works with MAC addresses. Right. Now, as technologies develop, give me a minute. So as technologies developed, we wanted that not only the switch, we wanted that similar, similar group PCs or similar group devices should be able to communicate with each other only. Not every devices that is connected to a switch should be able to communicate. So, for example, let's say this PC number 1 and 4, they should be able to communicate with each other, and PC 2 and 3, they should be able to communicate with each other. This is what we wanted. Okay, this is what we wanted. So it is very easy with just two PCs together. I can make that work. How? Okay, let's say I want PC number 1 and PC number 4 only to talk. What I will do is I will just make sure that the source MAC address is 1111 and 4444. Similarly, the destination MAC address is 1111 or 4444. Okay, so I want only these two combination of source MAC address and destination MAC address whenever I'm trying to send the data. Okay, based on that, this switch will be forwarding and receiving data between these two devices. The same kind of mechanism would work between PC number 2 and PC number 3. The source MAC would be 2222 or 3333, and the destination MAC would be either 222 or 333. And the PCs would be able to communicate between 2 and 3. Right? However, if let's say the source MAC address, for example, is 1111, and the destination MAC is, for example, 2222. Okay, that means it is this way. This is the communication that I'm talking about. I do not want such a communication to happen between the two PCs. It will not happen. Similarly, I do not want the communication between 4 and 3 to happen. Let's say the source MAC is 3333 and destination MAC is 4444. There will be no communication between these two devices. I want such a configuration. Okay. Also, let's say there are multiple PCs. Instead of 4 PCs, let's say there are 6 PCs. Okay. So 1, 2, 3, 4. Let me add one PC over here, PC number 5. Okay. And let me add another PC over here, PC number 6. Okay. I want, let's say that these PCs are one group and these PCs are another group. Okay. And the MAC address is 5555 and 6666. So what I want, if PC number 1, if PC number 1 sends a data, the data should be received by all the PCs in the same group. It should not be sent to any other group or any other devices. If PC1 sends a data, it should be received by the same group members. Similarly, if PC number 6 sends a data, it should be received by PC number 2 and PC number 3. These were my few requirements as the technology started to develop and as multiple devices were connected to a particular network. Okay, so if you notice over here, this particular small, or you can say this particular network that you see in front of you in the screen, where one single switch is connecting multiple PCs together, you can call it as a small network. Okay, you can call it as a small network of PCs. Okay, with small network, instead of calling it a small network, we started calling it as a local area network, which we basically commonly call it as LAN, local area network, LAN. Okay, so these 6 PCs together are forming a local area network amongst them. But inside this local area itself, I'm segregating them. I'm segregating multiple PCs. Okay, based on my usage. As I said, my usage was, or my condition was, these PCs should be from the same group, and these PCs are from the same group. Okay, so if as I said, my condition was, if one PC sends, if PC number one sends their data, it should be received by the same group members. Okay, so basically it's like a WhatsApp group. Okay, so let's say there are two WhatsApp groups, WhatsApp group A and WhatsApp group B, right? So A members will be able to communicate with each other. B members will be able to communicate with themselves, communicate among themselves, but communication between A and B will never happen. The same way, I want such a grouping of devices through a switch. On a switch, I want to make sure that the kind of grouping that I am looking for should be possible, where only those similar group of PCs should be able to talk to each other. And segregating these devices, or segregating these similar group of PCs from a LAN or inside a LAN, segregating multiple PCs inside a LAN by forming a common group, we call that as a virtual LAN. We call it as a virtual LAN, or in short, we call it as VLAN, virtual LAN. So these 6 PCs are in themselves a small network. In this small network, again, we are subcategorizing them, and we are calling it as a virtual LAN or a VLAN. All right. So this is the main purpose of VLAN. By segregating a smaller network even into smaller pieces, so that similar featured devices can talk to each other. Okay, it can be similar feature devices, it can be similar department, it can be similar data receiving devices can happen. Okay, let's say it's a big server room where there are printers, not server room, it's a big room of electronic devices, right? So there are printers on one side, there are PCs on one side, then there are servers on one side. So what I can do, I can segregate servers as one VLAN, I can segregate printers into one VLAN, I can segregate PCs into one VLAN. Okay, that is the working of, or that is how I can explain what a VLAN means. Okay, we'll understand even more better as we go through this session. Now, how do we segregate multiple devices through VLAN? Okay, first of all, we cannot configure a VLAN. Cannot. Okay, that's the word. You cannot configure VLAN on end devices. Okay, when I say end devices, I mean our PCs, laptops, printers, servers. You cannot configure VLAN on these devices. Why? Because they do not understand. They do not, first of all, they don't understand what is a VLAN. They don't understand VLAN. That is why there's no point, or you cannot even configure VLANs on these devices. Okay, where will you configure? Okay, you will be configuring them, configure VLANs on the switch interface, on the switch interface. Okay, now when I say interface, I'm literally talking on the interface. I've shown you the interface. I've shown you a switch with multiple interfaces. Yesterday, when we were doing the Cisco packet tracer also, I showed you the physical mode with multiple interfaces. We configure VLANs on the interface. So the only device in the LAN, the only device in the LAN which can understand VLAN configuration is a switch. Okay, the only device in the LAN which can understand VLAN is a switch, and that also we configure on the interface. Okay, we don't configure it on end devices. I mentioned with interface. Okay, so let's draw that same diagram. Switch number one, PC number one, PC number two, PC number three, and PC number four. Okay, this is, let's say, interface number one, interface number two, interface number three, and interface number four. Okay, so on this switch interfaces, these four interfaces, I will configure those VLANs. Okay, now VLANs can be configured from VLAN number one up till 4096. This is the range of VLANs that you can configure. Okay, this is the range of VLAN that you can configure, meaning that these are the different groups, meaning you can have 4096 groups that you can configure on the switch, and you can make different devices be a part of these 4096 groups. In normal terms, you can create 4096 WhatsApp groups, and you can assign members to 4096 groups. Okay, so members of different VLAN groups cannot talk to each other. Only same VLAN members can talk to each other. Okay, and who decides that? It is the switch who decides. Why? Because as I said, you're configuring VLAN on the switch interface. So switch will obviously know which interface is part of what VLAN. So for example, I configured VLAN number 10 over here. How do we configure? I'll talk about that later. Let's say I configured VLAN number 10 over here, and then I also configured this interface number 4, to be a part of VLAN number 10. Similarly, I configured interface number 2 to be a part of VLAN number 20, and interface number 3 to be a part of VLAN number 20. Okay. So when I configure the interfaces to be a part of similar VLAN, now the switch already knows that these two interfaces are part of the same VLAN, and these two interfaces are part of the same VLAN. Okay, so any data that is sent from PC number one, any data that is sent from PC number one will be received by PC number 4 only, because they both are part, the two interfaces are part of the same VLAN. Similarly, any data that is sent from PC number 2 will be received by PC number 3 only. If PC number 2 wants to send a data to PC number 1, it cannot send. Why? Because PC number 2's interface, PC number 2 is connected to an interface which is part of VLAN number 20, and PC number 1 is connected to an interface which is part of VLAN number 10. So they both are different VLAN members. The two interfaces are different VLAN members, and hence the switch will not forward the data. Okay, and hence the switch will not forward the data. Okay. before I move on, is this clear till here? What does a VLAN do, and how, like, what is this clear? What is a VLAN? First of all, how switch works with VLAN, I'm going to explain that right now. But is this till here? Is everything clear? Okay. Now let's try to understand. Okay, let's recap of how devices, not how devices, sorry, how switch forwards data. Okay, let me just give you a quick recap from past few sessions. These are the MAC addresses of these PCs. Okay, so if switch number one sends a data to switch number four, sorry, PC number one sends a data to PC number four. Okay, the source MAC is going to be 1111, and destination MAC is 4444. Right? Thank you. When this data is sent, what the switch will do? Switch will make an entry for the MAC address and the port number. Correct? The MAC address will be from the source MAC address, which is 1111, and it was received on interface number one. Then it looks for the destination MAC address. The destination MAC address is not present, so it's going to forward it out of all the other interfaces. PC number two is going to reject it. PC number three is going to reject it because the MAC address do not match. PC number four accepts the data because that is what the MAC address is. Now PC number four is going to respond. When PC number four responds, the source MAC is 4444 and destination MAC is 1111. Right? Now, when PC number four responds, switch one is going to check the source MAC address. Source MAC address is not present in the MAC address table, so it makes an entry for it and with the port number. Right? Then it looks for the destination MAC. The destination MAC is already present in the MAC address table, and to reach this particular destination MAC, it needs to forward the data out of interface number one. Right? This is what we had seen in our previous few classes. Now, with VLANs involved, okay, with VLANs involved, let's check how switch is going to forward the data or how switch is going to be. Now, when VLANs are involved in your MAC address table, a VLAN column is also present. Okay, a VLAN column is also present. And as mentioned, I said we will configure these two interfaces to be a part of VLAN number 10 and these two interfaces to be a part of VLAN number 20. How do we configure it? I'll talk about that configuration later, but let's just understand the forwarding mechanism of switch with VLANs in. Okay, again, let's consider the PCs know each other's MAC address. The switch's MAC address table is completely empty. Now, please remember, as I said, we have involved VLAN into the number 10, interface number 2, and interface number 3 are part of VLAN number 20. Now, PC number 1 wants to send a data to PC number 1 wants to send a data to PC number 4. Okay. Now, this data is sent. Switch number 1 makes an entry for it. Okay, it looks for the source MAC address 1111 and it was received on interface number 1. What VLAN is this interface number 1 configured for? It is configured for VLAN number 10. So it makes an entry. Okay, with the MAC address, port number, and the interface, and the VLAN number for this port. Okay, then it checks for the destination MAC address in the MAC address table, which it does not have. When it does not see the destination MAC address, what does it do? When it does not see the destination MAC address, what does it do? Can someone tell me? So when it does not see the destination MAC address, it should broadcast it or it should forward it out of all the interfaces. Okay. Technically, it should forward it out of all the interfaces. However, in this particular scenario, this forwarding of data will happen only on the interface which is part of VLAN number 10. Sees that the incoming interface is part of VLAN number 10. What are the other interface? Sees that the only other interface that is part of VLAN number 10 is interface number 4. So it will forward the data out of interface number 4 only. And it is not going to send the data to these two PCs. Why? Because they both are part of VLAN number 20 and not VLAN number 10, not a unicast data. This was actually a broadcast or flooding of the data by the switch. But since there is only one other interface that is part of VLAN number 10, it was forwarded to PC number 4. Okay. Any question here? Problem understanding this part? All right. So PC number 4 receives it. Okay. PC number 4 will receive it. And now PC number 4 is going to respond. Okay. PC number 4 will respond. Now, when PC number 4 responds, the source MAC address is 4444 and the destination MAC address is 1111. Okay. Now, PC number 4 responds. Okay. Switch 1 receives it. It will make an entry with the source MAC address 4444. It was received on interface number 4. Then it sees which VLAN does this interface belong to. It belongs to interface number, VLAN number 10. Okay. Next, it checks for the destination. Does it know what the destination MAC? Yes, it knows about the destination MAC. And is the destination MAC address port number part of the same VLAN which I received? Here, the receiving interface is part of VLAN number 10. Is the exit interface also part of VLAN number 10? Yes, it is also part of VLAN number 10. And hence, it will forward the data PC number 1. So over here, the switch is checking two things. Switch is checking, does it know the destination MAC? Also, the outgoing interface or the exit interface, is it part of the same VLAN of the ingress interface? So over here, the ingress interface, ingress means entry interface. Okay, the entry interface, right, or the ingress interface is part of VLAN number 10, right? The exit interface, the egress interface is also part of VLAN number 10, and that is port number 1. So the VLANs match. VLANs on the ingress interface and the egress interface match, as well as the destination MAC is present in the MAC address table. So now the switch is going to forward the data directly to PC number 1. All right. Any question or problem understanding this part? All right. Now, let's say if PC number 1 wants to send a data to PC number 2. The source MAC address is 1111. Destination MAC is 2222. This data is sent. Okay. Switch receives it. Switch has already made an entry. Source MAC address 1111, port number 1, and interface VLAN number 10. So it knows that detail of it. It looks for the destination MAC. The destination MAC is not present in the MAC address table, correct? When the destination MAC is not present in the MAC address table, what the switch is supposed to do? It is supposed to forward this data out of all the interfaces. It forwards it out of all the interfaces, but it will forward the data out of only those interfaces, which is a part of VLAN number 10, because the ingress interface, again, the ingress interface VLAN is very important. The ingress interface VLAN is VLAN number 10. So it looks for all the other interfaces which are part of VLAN number 10. And this flooding of data is only through interface number 4. This flooding of data will never ever go out of these two interfaces. And hence, this flooding of data will never ever be received by PC number 2. Okay, PC number 4 receives it, but PC number 4 will reject it because the destination MAC is not of PC number 4. The destination MAC is not of PC number 4. And in real time, we will not see any response coming from PC number 2 in this scenario. Clear? Any question or doubts with this particular situation? Now, thank you. Now let's understand from PC number 2 and PC number 3's perspective. Let's say PC number 2 wants to send a data to PC number 3. Okay, so the data is sent. Switch receives it. Switch will look for the source MAC address. It is not present in the MAC address table, so it makes an entry, interface number 2, and that VLAN number was 20. Okay, then it looks for the destination MAC address. The destination MAC address is not present in the MAC address table. And when the destination MAC address is not present in the MAC address table, the switch is supposed to flood this particular data out of all the interfaces. Yes, the switch will flood, but again, it will flood only out of interface number 3, because interface number 3 is the only interface which is a part of VLAN number 20. Why? Because the ingress interface, that is interface number 2, is also part of VLAN number 20. So the outgoing interfaces, which are the other outgoing interfaces that are part of VLAN number 20, which looks for them. That interface is only interface number 3. And this data is forwarded out of interface number 3. Okay. And since out of interface number 3 is already sitting, so PC responds. When PC number 3 responds, the source MAC is 3333, destination MAC is 2222. Okay. Destination MAC is 2222. Now PC number 3 responds. Switch makes an entry with the source MAC address 3333 received on interface number 3, and it belongs to VLAN number 20. Now it looks for the destination MAC. Is the destination MAC present in my MAC address table? Yes. Is the ingress interface, interface number 3 is the ingress interface or the entry interface, the outgoing interface, the incoming interface is 3, the outgoing interface is 2. Are these two interfaces part of the same VLAN? Yes, they both are part of the same VLAN. So switch number 2 is going to forward this data out of interface number 2, and PC number 2 will receive this data. Clear? Any question?
Yes, sir. Actually, if you are trying to ping from 3 to second PC, okay, if you don't have the MAC address table of the second PC, so it is trying to ping. Will it broadcast to every every VLAN or only to the VLAN 20?
Only VLAN 20.
Like, okay, it won't broadcast to VLAN 10, right? For the MAC address.
No.
Okay. Okay. Okay, sir.
Because
Thank you.
the incoming interface VLAN is 20.
Yes.
When it is, see, that is the main thing. It is checking the interface VLAN or the incoming VLAN interface. So here the incoming VLAN interface is VLAN number 20. So it is checking which are the other interfaces which are configured for VLAN number 20. That is only interface number 2. It does not know on this side, is it PC number 2, is it PC number 3, is it PC number 4, or is it a switch, or is it a server, is it a a data center? It does not. It only knows that on this particular interface, VLAN number 20 is configured. So I will
Okay.
forward this data out of only that interface. So the incoming interface VLAN is very important for the switch's decision.
Okay.
Clear? Got it?
Understand. Yes. Yes, please. Thank you.
Yeah. If you want more explanation, I can even again explain this once again. That I don't have any problem with it. You want me to explain the whole process once again?
No, no, it's clear.
Clear? Okay.
Yeah.
So let me show you this to a practical. Okay. So we have opened the Cisco packet tracer. What I'm going to do, I need one switch and 4 different PCs. So over here, I click on the switch and I'll drag and drop this switch over here, switch number 0. Let me rename it to switch number 1. Okay. Then I will put multiple PCs, PC number 1, PC number 2, PC number 3, and PC number 4. Okay. And let me drag and drop and let me add some IP addresses 10.0.0.1, 10.0.0.2, 10.0.0.3, and 10.0.0.4. Flipping each other, 10.0.0.2, 10.0.0.3, 10.0.0.4, 10.0.0.2, and 10.0.0.4. Okay. So yesterday we were looking at the switch CLI. Okay. So over here, okay. If you notice, the moment I clicked on the switches CLI tab over here, it took me to this particular format where I had to press return, right? When I press return, it started throwing me this particular prompt. And yesterday's class, we saw this particular prompt or mode is called as a user execution mode. And we have very less access to the switch features. So I had to type enable. And as I mentioned yesterday's class, I don't have to type the whole command. I just typed en and pressed enter. Okay, so the switch automatically understood en over here means enable, right? The moment I typed enable, and since I have not configured any, in yesterday's class, I showed you how to configure a password for enable as well, right? So since over here, I've not configured any password, it did not ask me for any password and directly took me to the privilege mode. Okay, user privilege mode, right? So I had to clear the MAC address table for a reason which you will understand probably a later point of time. But however, when I do a show MAC address table, okay, when I do a show MAC address table, right, you will see a VLAN column as well, along with MAC address and ports. Okay, till now, when I was explaining you the forwarding and receiving of data, I was only concentrating on MAC addresses and ports. But over here in today's class, we'll concentrate on the VLAN as well. All right. So to configure the VLANs, as I said, we configure VLANs, sorry, on the switch interfaces. Okay. And in yesterday's class, I showed you to configure something on a switch, we need to get inside the configuration mode. To get inside the configuration mode, we type configuration terminal. Okay. Or to come out of this configuration terminal, you can simply type exit. And to again get inside a configuration terminal, you can just simply write conf t. Okay, which is a short form for configure terminal. Okay. Now, what I want to do is I want to configure VLANs, right? I want to configure VLANs on the switches. And I want to configure only two VLANs for now, which is VLAN number 10 and VLAN number 20. So I will type VLAN 10. Okay. The moment I type VLAN 10, then I will exit this VLAN 20. Exit. Okay. Now exit once again. Now to check if these VLANs have been configured or not. This is how you simply configure the VLAN, or not configure, simply create the VLAN. I typed VLAN and the desired VLAN number that I want. Okay. And let me go back to the configuration terminal and show you how many VLANs you can configure. VLAN question mark. See here. It says from 1 to 4094, you can configure these VLANs. I can write any number between 1 to 4094. I chose VLAN number 10 and VLAN number 20. So you can configure VLAN number 1, 2, 3, 4. It's not necessary that you have to configure only 10 and 20. When you're practicing, you can configure any VLAN. You can even go to 1000 VLAN, VLAN 1000, VLAN 2000, VLAN 3000. Like it's just for from a practice perspective. Okay, I chose VLAN 10 and 20 because it's easier to remember. Because we obviously from childhood we are in a habit of counting 10, 20, 30, 40 very quickly rather than 1000, 2000, 3000. Right now, to check if these VLANs are created, to check if these VLANs are created, VLAN simple, very simple command, show VLAN, and you can see that two VLANs are created. You can see VLAN. The name of the VLAN is what VLAN is configured, VLAN number 10. The name of the VLAN is VLAN 0010. I did not give any name. It is the name given by the switch automatically. You can give a name to the VLAN also. Okay, you can give a name to the VLAN also. Okay, and currently the state is active for these two VLANs. VLAN number 10 and VLAN number 20 are active state. And you can clearly see under the ports, there are no ports under these two VLANs. Ignore these VLANs over here for now. We'll talk about them when the time comes. Okay, ignore these VLANs. But if you're curious, you can Google these VLANs for yourself. Okay. Over here, you can see under the port column, there are no port numbers mentioned. Okay. But for VLAN number 1, you can see all the ports. All the ports of this switch are part of VLAN number 1. Okay. This means that on a Cisco switch, since like most of my expertise is on a Cisco switch. I'm talking from a Cisco's perspective. Okay. With this, we come to know that VLAN number 1 is also called as the default VLAN. It is the default VLAN that you can see over here. It's the name also says it's a default VLAN. Okay. It says default VLAN. Okay, and by default, all the interfaces of a switch, all the interfaces of a switch are part of VLAN number one. Are part of VLAN number one. That is why that the pings from PC number one to different other PCs when I did the ping, I could receive the reply. I can receive the reply from the other PCs. Why? Because all these interfaces are part of VLAN number one. All these interfaces are part of VLAN number one. That is why the switch was able to send the data between the interfaces, because all of them are part of VLAN number one. All right. Now, we can see we have created two VLANs, VLAN number 10 and VLAN number 20, but no ports are given or no ports are assigned to these two VLANs. Okay, no ports are assigned to these two VLANs. Right. So how do we assign ports to, or how do we assign VLANs to a particular port? Okay, how do we do that? For that, again, we are configuring. So we need to get inside the configuration terminal. Okay, now in our topology, we wanted these two interfaces to be a part of VLAN number 20 and these two interfaces to be a part of VLAN number 20. Correct? Let's do the same thing. So this interface is fast Ethernet 0/1. So I will mention interface fast Ethernet 0/1. Okay. The moment I type this command, the moment you type interface, you are trying to configure a particular interface. And in this scenario, I'm trying to configure this interface, which is 0/1. I'm trying to configure 0/1 interface. And you can clearly see the moment I type this command and press enter, the command prompt has changed. Previously, it was just switch hashtag. When we get inside configuration terminal, it goes into switch config hashtag. Then when we get inside interface configuration, it goes as config if, meaning now it tells us we are in the interface configuration mode. So we are under the interface configuration mode. Now, when we are in the interface configuration mode, there are a lot of things that you can do. Let me just press question mark and you can see these are the different things that you can do on a particular switch. You can create authentication. Okay, these are different since we are we are going from basic to advanced. These things probably will be taken probably at a later point of time in the course. But these are different things that you can configure on this switch. Configure on the interface for a particular interface. Okay. So, but over here, as I said, I am trying to configure a particular VLAN on this. Okay. So to configure a particular VLAN or on an interface, I will type this particular command: switch port. Switch port. All right. Switch port. Then question mark. We have a switch port mode access. Okay. Then let me type the whole command and I'll explain you these command lines one by one. Switch port access VLAN 10. All right. Now I have introduced two new commands to you and two new command prompts as well. One is a switch port, the other is a mode access. Now, what does this mean? It's just you can for a switch port, you can just understand on this interface or on this port of this switch. Very simple mnemonic. This command prompt has no particular significance other than whatever you type later is what is important. Okay. So over here, let me go back to the meaning of this. It says switch port set switching mode characteristics. Okay, so on that particular interface, on this particular interface, that is interface 0/1, I'm trying to set some features or characteristics to that interface using this command. Okay, so you can say that of the the port, which port 0/1 port of this switch, I am creating or I am configuring this interface to be part of VLAN number 10. Very simple way of understanding this. Okay, so first one was switch port mode access, meaning that this interface 0/1, the mode is access, and once the mode is access, this interface is part of VLAN number 10. Okay, the port of this switch, I am creating or I am setting the mode to an access mode, and once the mode is set as access, I am configuring VLAN number 10 on that interface. Very simple commands. Switch port mode access, switch port access VLAN number 10. Okay, now exit, exit. Let's do a show VLAN to see the VLAN difference. Over here, you can see that difference. Now fast Ethernet 0/1, you can see under the ports, fast Ethernet 0/1 is now configured for VLAN number 10. Is configured for VLAN number 10. Earlier, you can see here, fast Ethernet 0/1 was part of VLAN number 1. But after the configuration of switch port configuration, switch port mode access, switch port access VLAN 10, you can see fast Ethernet 0/1, fast Ethernet 0/1 to be a part of VLAN number 10. All right. Similarly, I have to configure 0/2 over here to be a part of VLAN number 10. So that PC number 4, this interface is also part of VLAN number 10, right? So the same configuration, configuration terminal interface. Now, instead of 0/1, we are going to configure for fast Ethernet 0/2 switch port mode access switch port VLAN switch port access VLAN 10. Okay, then instead of typing exit twice, I can just simply write N. It will directly take me. It will exit out of every configuration modes and take me back to the privileging. Now let me do a show VLAN. Now, sorry, yeah. Now you can see interface 0/1 and 0/2 are part of VLAN number 10. Are part of VLAN number 10. Okay, they are no more part of VLAN number 1. They are part of VLAN number 10. Okay, now one thing you may ask me, what is the meaning of access? I have mentioned switch port mode access. Then I have mentioned switch port access VLAN 10. But what is the actual meaning of access? Access means that, or access mode means that access, we already know the actual meaning of access. Access, we know that it's an English word, which means giving permission, giving us permission to do something. Okay, technically to give permission to enter or exit from somewhere. You have access, let's say you have access to the server room, meaning that you are the person who can enter the server room or exit out of the server room. Similarly, here, when I say access, it means that I am telling this interface that you should allow only interface number, sorry, a VLAN number 10 data and VLAN number 10 data only to exit out of this interface and enter this interface. You should only allow one interface, that is VLAN number 10. So access mode means that only one VLAN can enter or it can exit out of that particular interface. And what VLAN is it? We configured it for VLAN number 10. We configured it for VLAN number 10. Clear? That is the meaning of access. Only one VLAN. Only one VLAN. That is VLAN number 10. Clear? Any question? Okay. Now, similarly, we'll configure for VLAN number 20. Configuration terminal, or the interface number 0/3 and 0/4. Okay. So interface fast Ethernet 0/3 switch port mode access. Okay. Then switch port access VLAN 20 exit interface fast Ethernet 0/4 switch port mode access switch port access VLAN 20. Okay. Then exit. As I said, you don't have to type exit multiple times in order to reach this particular prompt. You can simply type end and it will exit out of all the configuration modes and it will take you to the provision. Let's do a show VLAN. When we do a show VLAN, now you can see the two interfaces 0/3 and 0/4 are now configured for VLAN number 20. Are now configured for VLAN number 20. Okay, so this is how you configure VLANs on a particular switch interface. Okay, switch port mode access, switch port access VLAN and whatever the VLAN that is supposed to be there. All right. Now let's try to ping. Okay, let's try to ping from PC number 1 to PC number 4 or whatever the other pieces. First, let's check the MAC address table. Show MAC address table. Okay, the MAC address table is empty. All right. Now let's try to ping from PC number 1 to PC number 4. Okay. So let's try to ping from PC number 1 to PC number 4 and let's check how is the switch working over here. So command ping 10.0.0.4. Okay. Now when I do a ping, you can see a packet is created. Okay. Packet is created. And here the destination MAC is 76A1, which is PC number 4's MAC address. And this is B4C8, which is PC1's MAC address. Okay. So source MAC is B4C8. Destination MAC is 76A1. Okay. Now this packet is forwarded to the switch. Okay. Now switch will make an entry. Okay. Switch will see for the source MAC address, right? Source MAC address as B4C8 and this interface is 0/1. And what VLAN was it configured for? It was configured for VLAN number 10. So let's check. Show MAC address table. We'll see the same thing, right? B4C8 0/1 and VLAN number 10. Okay. Now the next thing it checks the destination MAC. The destination MAC address obviously is not present in the MAC address table. And in this scenario, if the destination MAC is not present in the MAC address table, what is this switch supposed to do? It should flood it out of all the interface. Correct? This is what we have seen. But in this scenario, with VLANs configured, these two interfaces, part of VLAN number 10, these two interfaces part of VLAN number 10 and these two interfaces to be a part of VLAN number 20. Now let's see what the switch is going to do. The destination MAC is not present in the MAC address table. The switch, what is it going to do? Next. See here. Switch forwarded it out of only this interface. It did not forward it out of these two interfaces. It did not forward it to these two. First, the switch checked the incoming interface is part of VLAN number 10. In the MAC address table, it will open the show VLAN table. It opens the show VLAN table that are part of VLAN number 10. The incoming interface was 0/1, which are the other interfaces that are part of VLAN number 10. That is 0/2 only. If there were other interfaces, let's say 0/5, 0/6, 0/7 interfaces as well. But in our scenario, only one interface is part of that particular VLAN, and hence the data was forwarded out of that interface. Okay. The switch does not know that PC4 is connected to that interface. Please remember, the PC is unaware that the other interface, which is part of VLAN number 10, is 0/2 VLAN interface. And hence, the switch forwarded the data out of this interface and PC number 4 receives it. Coincidentally, PC number 4 is connected over here with the destination MAC, correct destination MAC. So PC number 4 will accept it, right? When PC number 4 accepts it and sends back the data, what is the source MAC? Source MAC is now going to be reversed. 76A1 and destination MAC is going to be B4C8. Okay. When PC number 4 replies, switch is going to make an entry, correct? Switch is going to make an entry for the source MAC address in the MAC address table. So it made an entry. See here, 76A1, which was received on 0/2 with the VLAN number 10. Then it checks the destination MAC address. Is the destination MAC address present? Yes, it is present. Is the incoming interface VLAN and the exit interface VLAN, are they part of the same VLAN or not? Yes, in forwarding the data out of that interface, and hence PC1 was able to receive that data. So over here, you can see a reply. You can see a reply. And this is how PC1 and PC4 are able to communicate. PC1 and PC4 are able to happen between these two PCs as well. Between these two PCs as well. When I try to ping PC number 3, when I try to ping PC number 3 and PC number 2 over here, the same working will happen in the switch. Okay, switch will, PC will forward. It checks the incoming interface as 20. It will not see PC number 3's MAC address in the MAC address table, and hence it will flood it out of all the interfaces which are part of VLAN number 20, and PC number 3 will receive it. Okay, PC number 3 will respond. Switch will see that the incoming interface is part of VLAN number 20. The outgoing interface with the destination MAC is also part of VLAN number 20, and PC number 2 will receive that data. Okay. Any question? Any problem understanding this part? No. All right. Now, let's try to see if what will happen if I try to ping PC1 and PC2. PC1 and PC number 2. Okay. So let me write that down. This is 10 and this is 20. These two interfaces are part of VLAN number 20. These two interfaces are part of VLAN number 10. Now, from PC number 1, let's try to ping PC number 2. That is IP 10.0.0.2. Enter. Okay. Let's note down the MAC addresses. The source MAC, PC number 1's MAC address, which is B4C8, and destination MAC is CA98. CA98. Okay. So what is going to happen? Let's check that. And as we discussed, PC is going to forward the data to switch, right? Switch will receive it. And when switch receives it, what the switch is going to do? It already has an entry for B4C8 on 0/1 with the VLAN number as 10. It already knows it. Okay. So over here, when we do a show MAC address table once again, there will be no change. Right? You can see here, there is no change. Right? Then it checks the destination MAC address, CA98. It checks for the destination MAC address. It is not present in the MAC address table. So if it is not present in the MAC address table, it is supposed to forward it out of all the interfaces. Will it do so? Will it forward it out of all the interfaces? No, it will forward it out of only those interfaces that are part of VLAN number 10, right? So over here, next step, you see, it forwards it out of interface 0/2 only. It did not forward it out of these two interfaces, right? And PC number 4 receives that data, but PC number 4's MAC address is not CA98, and hence you can see PC number 4 is rejecting that packet. That literally means PC number 2 never received this data because it is connected to a different VLAN interface. And hence we will see that PC number 1 will never ever receive a response from PC number 2 in this case. See here, pinging request timeout, meaning that it requested PC number 2, but PC number 2 has not responded and the request has timed out. And you know the reason now why it timed out, because the two PCs are connected to different VLAN interfaces. Clear? Any question? Okay. If no questions, I'll stop our class today over here, and then we'll continue our discussion more on VLAN tomorrow. All right.